Artificial intelligence is bringing in a new era of medicine. Algorithms combined with advanced robotics can aid everything from diagnostic imaging and analysis to remote surgical assistance and even autonomously performed procedures. The data collected by rehabilitation devices and prosthetics could also improve individualized recovery in patients. In the July special issue of Science, experts offered insight on how these extraordinary advances bring hope for more consistent and effective treatment in the future. The future of surgery is likely to include robots with some ability to work on their own. Surgical robots are classified by their level of autonomy and the degree to which they use algorithms to make medical decisions. Level 0 robots have no autonomy and rely on a human operator to perform surgical procedures. Level 1 robots make use of AI to provide assistance with procedures, but still relies on human control. At Level 2, robots have autonomy over certain tasks. Repetitive or tedious subtasks within a procedure, like cutting cancerous tissues, are assigned by surgeons to the robot. Conditional autonomy at Level 3 involves robots generating a strategy or list of strategies for a task, but still relies on a human to select or approve the strategy. The smart tissue autonomous robot operates at this level, applying machine learning to generate and execute a plan for suturing. This is currently the highest level of autonomy possible with today's technology, but advances on the horizon may bring us closer to fully autonomous systems. Image-guided robotics combine computer vision with images from cameras, ultrasound, MRI, or CT scans to identify key anatomy and precisely direct robots to targets. Early applications of AI in image-guided robots were focused on steering needles through soft tissues to reach targets for biopsies. Now, attention is moved on leveraging AI to understand images on a higher level and make more accurate navigational decisions. Interpreting images on a fine scale and changing course based on that information could lead to autonomous ultrasound scanning or self-guided maneuvering of devices for endoscopies and minimally invasive surgeries. A significant challenge that remains is the high level of expertise required from radiologists and surgeons to train the algorithms that control this technology. Still, robotic systems that can see and interpret their surroundings are likely to have a more prominent role in the future of medical care. Surgical technology already uses robots to assist in minimally invasive surgeries, but the rigid components of current surgical robots limit access to certain areas of the body, and in some cases can cause tissue injuries. Researchers have been exploring the potential for soft robotics made of pliable materials that can stretch, bend, compress, and shift from soft to rigid. One notable project was the EU StiffFlop project. StiffFlop developed a soft robotic system from biocompatible silicone that used advanced machine learning for its teleoperation. It remains an open question whether soft robotics will develop the precision needed for intricate surgical applications, or whether traditional surgical robots will acquire some of the properties of soft robotic technology. Wearable robots could transform the rehabilitation experience for both patients and health professionals. Hard mechanical exoskeletons and soft robotic exosuits already in development can improve patient outcomes and offer the assistance needed to get back to daily life. The transformative potential for these wearable robots, however, comes from the data that they can collect. The ability to continuously track movement and adjust robotic assistance based on personal progress could revolutionize rehabilitation. But the challenge in these systems is in the calibration of devices that separate signals of recovery from noise in the data. Sensor placement, day-to-day fit of devices, and regular variability in how patients' bodies feel and function are among the many complicating factors in developing generalized algorithms to allow widespread use of wearable robots. Artificial intelligence is tightening the relationship between robotic prostheses and their users. Machine learning algorithms allow robotic limbs to sense intended motion through neuromuscular signals, enabling more seamless control of prosthetic hands and motorized lower limbs. This relationship is developing even further with machine vision designed to sense the surrounding environment. Prosthetic legs that can see upcoming terrain can help the user adapt to their environment. These advances have the potential to restore and enhance prosthetic users' abilities to complete everyday tasks. In addition to meeting high standards for safety, developers will also have to gain users' trust in the idea of AI-enabled limbs. As medical technology continues to develop, artificial intelligence will play an expanding role in how we diagnose, treat, and understand the human body.
Hi, good morning. Let's start today's class. Hi, thank you. Hi. Today's content is a medical robot, so therefore we have started this Science Magazine's movie. Yes, we should go back to today's slides. Yes, here we are in the social robot, one of the social robot. Today is a medical robot focusing. And next week, we should focus on the welfare. And 2 weeks later, the rehabilitation robot. Yes, 3 series of the medical and rehabilitation robotics. Yes, and today's content looks like this. And firstly, the medical robot, type of medical robot, what it is. The one categorization looks like this. The surgical robot, rehabilitation robot, hospital something task robot, and telemedicine. In the medical robot, we should mainly focus on the surgical robot because this is the most advanced technology should be used as a robotics technology. So therefore, we should focus on this today. And when we see some categorization of robotics, so this is today I have shown this Science Magazine's movie. This looks like this. But also the medical robot Wikipedia shows some categorized into several types. This categorization is also looks like this. The surgical robot, firstly is a surgical robot. Secondly is a rehabilitation robot. And third is a bio-robots, a group of robots designed to imitate the cognition of humans and animals. Yes, some of the biomimetic robot looks like this. And the telepresence robot, remotely operated, or the robot works as a remote agent of operator. And the pharmacy, this is one of the in-hospital robot, companion robot, supporting robot. And the disinfection robot. This is also the disinfection is also the one important things because we have experienced the COVID diseases. So therefore, this disinfection in surroundings is a very, very important work presently. Hospital robot, robotics, prosthetic. This is like the rehabilitation. So the artificial prosthetic is also the important thing, one of the medical robot. This categorization looks like this. But we today mainly focus on this. Next, これだ。で、surgical robot. And then I have introduced some of the surgical robot. It looks like this, looks like this. And as the previous video says, the AI technology is supporting this. This video is how AI pushing the medical robot award autonomy. It's this Science Magazine's video is also here. Yeah, so therefore I will ask in today's content, which part you are interested in, or you want to discuss with others or someone. Yes, today's questions, 5 questions given previously is orthopedic surgery robot, endoscopic surgery robot, endovascular surgical robot, autonomous robot surgery, broken of the to the robot surgery. It's the 5 questions I have given. So therefore, firstly, I will ask which part you want to discuss, not only limited in these 5 questions, but which part you want to discuss today, or you want to know more today, interest or questions you have, I will ask about it. Okay, firstly. はい。まずは、firstly, UA, which part you are interested in today's contents?
I'm interested in the vascular surgery.
Vascular surgical system, yes. Part 5. Vascular surgery. Yes, it's good. Why you are interested about it? Vascular surgery is mainly in today's content is バスキュラーサージェリーってどこだっけ？バスキュラーサージェリーってこの辺か？エンドバスキュラー。エンドバスキュラーサージェリー。これか。この辺。Yes, around here, the blood vessel. Through blood vessel, we are doing this kind of the robotic system. Yes. Why you are so interested about this?
Cure the vessel disease.
Cure diseases. Okay. いいや。はい。Thank you. Thank you. Next, the channel. Which part you are interested in today's contents?
Question for the autonomous surgery.
Oh.
Because actually, I give the reasons in the 5 that I said that to train a human for over a decade merely to serve as the most delicate manual operation on the surgery table is, in essence, a way of subjecting the human mind to repetitive labor. So we think even for the doctors, the surgical doctors, they should also come back to thinking, not operation.
ちょっと more exactly, what do you want to say?
Actually, I'm curious of the question 4, the autonomous surgery robot.
Yes.
Because I think for the work of the doctor, they should think, not operate. So we need this, and we should talk about how to accomplish this.
Doctor's task とか doctor's role, you want to know? You want to discuss?
Right.
Okay.
It means I don't want to discuss the doctor's role, but actually this is only the supporting sentence for why I want to discuss the autonomous robot.
Okay. はい。Thank you. Yes. じゃあ next, which part you are interested in today's contents?
Endovascular birds. Because I think it is very small and it needs to travel through the blood, having the blood vessels. And so I'm curious how it can move smoothly through the vessels. And I also want to know I also want to know if the which will have will blood will imperfect uh, uh, and I also want to know if it interferes with blood movement as it enters that.
Moving through blood vessel is one interest you think. Okay. はいはい、thank you. じゃあ、finally, the Ifan, please show us which part you are interested in today, the contents. Okay. The question one ってなんだっけ what was question one? Orthopedic surgery was? Orthopedic. Why you are interested in about this part?
Yes, because I find that in the field of the orthopedics, some robots have very impressive capability to assist the surgeons during during the operation, and some can provide the real-time navigation and the real-time 3D reconstruction during the surgery. So I find that some robots is very strong.
まあ、3D simulation か。Simulation, for example, the 3D simulation is very important for planning before the surgical operation. This is combination of image processing and the planning, robot planning and execution. Yes. じゃあ、today we should start from the question 3 か。Endovascular surgery. Vascular surgery. Yes, question 3. So we should start from this. And so therefore question 3のコンテンツは何ですかって言ったら、Endovascular surgical explore and explain the endovascular surgery where robot has been used and on the role and function of the robot in endovascular surgery. What it is and what kind of movement they are doing in this operation. So we want to hear from. Yes, yes. じゃあ、from students. ペンチェン、yes, yes, okay. Who will do? Then you will.
Explore and explain the endovascular surgery where robots has been used. The endovascular surgery is a surgical subspecialty
Okay. Yes, yes.
Subspecialty in which vascular diseases involving the arterial veins or lymphatic vessels are managed by medical therapy, minimal invasive catheter procedures, and surgical reconstruction, and the roles and functions of the robot in endovascular surgery. First is enhance the precision and stability, the motion scaling, allowing macro movements to translate into micro movements, stable catheter platforms, reducing vessel wall trauma, and it's improved navigation in anatomy. The multi-directional steerable catheters overcoming limitations of pre-shared convention catheters. The 316 degrees instrument hinge for accessing tortuous vessels.
This. In your explanation, endovascular surgery, what the actual task for doctors or robots to do in endovascular surgery? Yue, can you reply to this question? Actually, what is the task of doctors' usual work or the robot to do?
The camera through the vessels.
Camera, and looking from inside the vessel.
Yes.
The only looking is not good enough for the medical treatment. So therefore, what is the operation of robot?
Uh,
Hmm.
to kill the vessel,
Cure the vessel. Okay.
vessel or trauma.
Tumor, no, but
Vessel wall. Wall.
vessel wall.
Yeah.
Vessel wall caring. Okay, that is your answer, yes. Yes, thank you. Next student's answer.
Okay, for the person, for the Indo, sorry.
Hmm.
There's doing some problems already.
Okay, please.
For here we come to the for here we come to the for the we come to the endovascular surgery robot.
Hmm.
And for the instructions in the vascular surgery involves minimum investment, proceed and performed within blood vessels to treat various vascular diseases. So we need to operating system that could go through the vessels and to be drained or pushed in the place that the operation should be done. So we are trying to introduce a kind of machine called Corpus. Corpus is a traditional vessel robot. It doesn't need some autonomous or automatic driving system that makes the operation system in go straight to the place that need to be cured. It's using a string that's pull and push uh, the operating system, and when it is placed, it could be easily to uh, get the vessel information by the X-ray test because the X-ray examination because the reflection of this corpus operation system is very strong and easily to know the actual actual status of the vessels itself, and when it goes through into the place it could just inflation and make the uh, it could just inflation and put the medical traits in the uh ちょっと待って。
Hmm.
Put the bracket on the bracket inside of the vessel and make it spread and conquer the narrative of the vessel to deal with this surgery. For what is the basket? It is
Hmm.
it's I didn't prepare the last night, but now I could show a picture here. This is called a basket, and for the core parts, it is actually that for the string part, it could be supervised by remotely, so that the doctors need not to be the doctor needn't to be under the X-ray exposed.
Okay, okay. Hi, thank you, thank you.
Okay.
Yes, yes, this kind stent, this kind of mesh type is called stent.
Yeah.
Okay.
Next, the Promotion is the
ちょっと、これ、チェナ、これ、クローズ、yes, yes. マオシャンか。
I know, although I know less about the endovascular surgeries, but has studied some information from the wiki. The endovascular surgeries, there are different classification of endovascular surgery into vascular system, arteries, veins, and circulatory system, and so on. And it can cause large annual aneurysms, carotid artery disease, peripheral artery disease, and venous disease. It usually involves the use of mass turbine to support the blood vessels, and a probe tube is inserted into the blood vessel to perform the procedure, and it can also treat cardiovascular diseases.
Aneurysm, aneurysm repair. Okay.
Sorry.
で、アニューリシスって、why this kind of disease will appear inside of the vessel?
And I should search more about that.
Why this kind of disease happened inside of the vascular system, vessels?
Actually, I know less about this disease. I only know it is happened in the vessel.
Okay. Sometimes it happens in some patient. Okay.
Yes, the insurance.
Non-vascular surgery is a minimally invasive vascular surgery. Surgeons use tiny incisions to thread catheters to damaged blood vessels. They use endovascular surgery procedures to remove blood clots and improve blood flow. Endovascular surgery can help reduce risk of heart attack, stroke, and other life-threatening conditions. One example is a co-pass GRX system. and Xiao introduced it right now, and it is used in percutaneous coronary interventions such as placing stents in blocked coronary arteries. Compass GX helps to create a safer work environment for interventionists by allowing operators to perform procedures from a radiation shielded workplace with automated procedural movements and precise anatomical measurements. The robotic system also help operators navigate complex anatomies more consistently and predictably, aids in selections of the appropriate stent and ensures accuracy in device positioning. And another example is SensiX. SensiX is a specialized robotic catheter system that is controlled by a physical and is designed for accurate positioning, manipulation, and stable control of catheter and catheter-based technologies during cardiovascular procedures as open surgical procedures that require large incisions have given way to minimally invasive surgeries in which the surgeon gains access to the target organs through small incisions using specialized surgical tools. One important tool used in many of these procedures is the catheter used to deliver many of things a surgeon needs to do before impact target tissue and deliver a variety of medicines or disinfecting agents to treat disease or infection.
OK, OK。いいか。ちょっといい感じ。I have a question.
Yes.
You provided the two examples of robots,
Yes.
Corpus GRX and Sensei X. What is the difference or typical feature of each robot system? Can you say something about it? なんか difference とか。Why these two products is now be here? なんか one is this.
So the core path is the main work is to provide emotional operation workspace, and the Sensei X can used to deliver some medicines to the target place.
OK, OK. はいはい、Thank you. Yes, yes. じゃあ、ちょっと I will say something about it. Thank you. I will add some information about it. 共有。このなんか、この endovascular surgery is the inside arteries or the veins or lymphatic circulations to some diseases. For example, the aortic aneurysm, as the Haushan said, the cardiac artery diseases, some diseases, and the peripheric artery diseases, vein diseases. This kind of plaque is inside of this vessel, and the blood flow will be disturbed or obstructed by this kind of plaque or some blocks. So therefore, it should be removed or should be make the inside vessel larger. So therefore, one of the way is this kind of stent is given here and pushing it from inside and making it larger. So therefore, the inside vessel surgical operation will be there. The catheter って、this kind of、ちょっと待ってね。history and risk of benefit endovascular annulation。ここら辺のやつなんか見ればいいのか。history and endovascular surgery。探しましょう。We will see this. そうか。これか。よいしょ。
Hello, I'm Dr. Kim Hodgson, and this is a Society for Vascular Surgery briefing about the history of endovascular surgery. The term endovascular refers to the treatment of blood vessel disorders from inside the vessel using balloons, stents, and other devices. These less invasive treatments, while not suitable for all patients, avoid the incisions, anesthesia, and convalescence typical of alternative surgical treatments. The earliest endovascular procedures provided only diagnostic information, demonstrating areas of atherosclerotic blockage or aneurysmal degeneration, which were subsequently treated with surgery. The last 2 decades, however, have witnessed an evolution of technological innovation that now allows many conditions to actually be treated with a minimally invasive endovascular procedure. The earliest of these therapeutic interventions that is still routinely utilized is simple balloon angioplasty, which enlarges the flow channel of a blood vessel narrowed by atherosclerotic plaque by fracturing the plaque and stretching the blood vessel. While balloon angioplasty is sometimes sufficient treatment on its own, irregular fracturing or recoil of the plaque can compromise the results and led to the development of stents, which support the fractured plaque while it heals. Since the original Palmez stent was approved for use nearly 20 years ago, technological advances have made stents more flexible and their delivery systems smaller, both of which result in an easier and safer treatment. While a definite improvement over balloon angioplasty alone in many situations, stents are not always effective, which has led to current research into drug coatings on stents and balloons, which it is hoped will further improve the results of endovascular therapy for atherosclerotic blockages. Evolving along a parallel track, endovascular treatment of degenerative aneurysms of blood vessels using stents covered with fabric, termed endografts, shares many similarities to treatments for atherosclerotic blockages, but with key differences. While devices to treat blockages result in improved blood flow, endografts are designed to prevent aneurysm rupture by effectively relining the weakened segment of blood vessel. Originally developed to treat aneurysms of the aorta and the abdomen, further evolution of these devices now allows a variety of conditions affecting the majority of the aorta to be treated with an endovascular procedure. Even when not solely treatable by an endovascular means, hybrid endovascular and open surgical procedures have been developed to allow an expanded list of conditions to be treated in a less invasive way. Research is currently underway to develop endografts to address the remaining conditions and locations currently only treatable by open surgical means. This briefing is made possible by a grant from Cook Medical. To learn more about vascular health,
So therefore, maybe you can understand some of the outline. Yes, endovascular means inside of this kind of small vessel, the catheter. Catheter is one device to insert it inside. This kind of catheter is inserted inside the vessel, and then sometimes balloon is used to make the opening, the vessel, inside the vessel, the narrowed part. And also the stent is put inside of the vessel to keep its shape. So therefore, this catheter should be flexible to go through inside the complicated pathway of the vessel. So therefore, firstly, the manually, started from manually, not using the robot. So therefore, the very wire-like the catheter is inserted by surgeon's operation hand. But presently, the robot, the inserting system, and also this end tip part of the catheter is become bending by the surgeon's operation. Like this is the operator's operation device. It looks like this. And the other operation devices, the joystick-like devices is also used. So therefore, this kind of operation devices, this kind of the joystick type is also used. So while monitoring the catheter's position and also the complicated vessel's 3D images, the surgeon is moving these devices, go back, or bending or something the operation is doing. So therefore, I will show some latest devices like this. Maybe this is good to see. これでどうするかって言ったら、ここで探して、動画探して、これか。これでいいと思うんだ。はい。This robot is made by French company, University Hospital. This is a setting and the monitoring is like this. And the monitor this small vessel position. And this is a catheter is inserted from here. The operator is using two joysticks, watching this kind of image. This robot device is ended there. Yes, the operator is making this joystick operation, two joystick operation. Inside of this. Go back, and go through. Just bending like this here. From here, this catheter is bending.
J'ai été honoré de pratiquer cette intervention à l'aide du robot. Ça s'est déroulé exactement comme on avait prévu. On avait pu utiliser le robot au bon moment. La navigation à l'aide du robot est précise et de l'ordre du millimètre, ce qui est pour nous capital pour naviguer dans des artères qui sont microscopiques. L'irradiation des opérateurs est nettement et drastiquement réduite par le fait d'être protégé et déporté par rapport à la source de rayon X. Le fait de pouvoir utiliser les propres guides et cathéters qu'on avait l'habitude d'utiliser manuellement se branche naturellement avec le robot, ce qui rend les choses très faciles d'accès pour n'importe quel neuroradiologue interventionnel. La neuroradiologie interventionnelle va prendre en charge des patients victimes d'accidents des vaisseaux du cerveau, d'AVC. Il est nécessaire de réduire le plus possible les temps de prise en charge. Or, malheureusement, on ne peut pas avoir des neuroradiologues dans tout le maillage territorial et il est donc nécessaire de pouvoir déployer cette expertise endovasculaire dans différents centres. Le robot pourrait être le vecteur, le moyen qui nous permet de déployer cette expertise en permettant au plus près des patients de prendre en charge dans des salles d'angiographie avec le robot et à distance, le neuroradiologue interventionnel apporte son expertise technique pour la navigation au sein des vaisseaux intracrâniens. On peut ainsi imaginer que la robotique endovasculaire permettra une meilleure prise en charge des AVC.
ということで、まあ、one of the most important merit of this kind of robot system is it can be remotely operated. So therefore, the expert would be in the single places, but to the multiple place, remote places, robot can be operated by this single operator or expert. So therefore, this kind of thing. Well, this robot is a newly launched RoboCast incorporation. This kind of catheter is inserted from this end chip robot, and then this robot's insertion and the bending movement can be operated by this kind of the operation devices. というのが endovascular surgery. When they reach to the places to expand the narrow part or to move inside or be able to reach to there. The one way is the balloon is extend the balloon and also extend the stent, and the stent is put remaining inside of the vessel to keep its diameter for blood flow. You know, this is one endovascular surgery. この stent and balloon system is the necessary to もうちょっと大きくするとこう balloon system is here like this. ですね。この the center part is a catheter, and this is inserted from for example, the waist or other part, and then it is reached to here. And this is one thing we should. はいはい。これは this is the endovascular system で、もう this kind of catheter system, one thing is this part, end chip part should be flexible to bend. And also the force technology provide force feedback. So too complicated pathway, this catheter should be inserted. So therefore the force feedback is very important for the surgeons. The hand feelings, some burden or bending is also very important. They provide remote robotic control diagnostic devices, precise movement for devices, stability とかっていうのは one important thing, this robot technology. で、これも level of precision とか improved care for patient because the operation time should be shorter as much as possible. And remote communication とか remote countries, the places it can be done. っていうのが書いてますね。はい。This is the endovascular surgery of remote operation. なんか、do you have some more question about this topic? Yes, if it is no, we should move on to the next some topic like yes, じゃあ、なんだっけ。オートマスロボットね。オートマスサージカルロボット。So therefore, please explain about this question for the part. Question 4ね。オートマスロボットサージリー。Explore the list of necessary technology to realize autonomous robot surgery. Examine and consider the contribution of AI technology for that purpose. っていうのは、まあ、I have shown the video, but please show us each student's answer to this question 4, please. Yeah. attention, please. Okay.
I actually didn't say something about nowadays. I didn't say something about the nowadays trial, but I actually talk about the still problems and actually methodologies, because nowadays the examples are actually more practical and actually in the medical science. It is this autonomous robot surgery is actually definitely not a medical problem, but a robot problem. So we need to think about the things that's more based on robotics. So these days, the medical surgery robots examples didn't really represent it. We could think about it. What is the autonomous surgical robot? It's just by operating a system that's based on some knowledges and doing the fairly fine, fairly precise operations in a limited space, in limited angles, just like this. So as we introduce as we developing the autonomous robot surgery, we are basically need this part of uh, uh, this kind of abilities, that the advanced imaging and sensing system, surgical task decomposition and policy learning, and also the real-time data processing and decision-making algorithms. Why I say these are the most important, why I say the surgical part is not, but this part is, because the surgical part, we nowadays the remote control robots could do. The Da Vinci is good enough to do the surgery operations. So we just need to know how to make the robots do and calculate for the tasks. So why the imaging and sensing system is more needed? Because the human beings could have much more consciousness about the touch, the feedbacks, also the tracking, the stick of the knife, and this part of the information that is difficult to be a training information to the robotics. So we need a better sensor part that could contains more image and structural information that makes the robots easy to do the decisions. And also the surgical task decomposition and policy learning. Because of the surgical task, actually a long period operation that included much more steps. So we need to make the all surgery into some steps that could be reproduced and recombined together. So we shouldn't do robots that could do some kind of surgery, but the robots that could do the movements of the surgery. So we need to separate the surgery operation into moves to moves. From the actions to actions. And the third, real-time data processing and decision-making algorithms. Actually, nowadays, the big models, just like the large language models, there are still need about 15 or 30 minutes to do the feedback for a routine calculation, and then for the medical input, it could be longer. So this could be some problems that for the surgery calculation system. However, nowadays we could imagine that we could solve this problem. It's because the AI's progress that we could imagine methods that we could solve this problem. We face the difficulties because we are able to solve these difficulties. Just for the computer vision for tissue recognition, is actually we have progressed a lot, and the machine learning and the surgical cure accuracy. Now the large language models could easily, according to the descriptions of the descriptions and give the right answers for many kind of for the many subject, and also the predictive analytics for outcome optimization, just like nowadays the automotive could drive autonomous driving that using the predictions. If we don't have these, we just cannot think about the difficulty is. Thanks a lot. Here are my reply of the question 4.
Okay, good. From others, do you have some question? ペンちゃん、do you have some question to say now? No? Yes, yes. じゃあ、thank you.
Thanks,
Thank you. じゃあ、next student. Yes, please.
I also have a question for you. Firstly, the necessary すみません. Firstly, the necessary technology to realize the autonomous robotic surgery is, I think, have 3 points. Firstly, it first needs to have high precision perception capability, such as 3D imaging with real-time intraoperative navigation systems, and enable the robots to accurately recognize the patient's anatomy. And secondly, the high degree of freedom robotic arm control technology is fundamental, allowing the robot to perform delicate maneuvers with the dexterity of a human doctor. And at the end, the force feedback system helps the robots determine the hardness and the tensile of tissues, and to avoid harm to the injuries. And after that, for the AI technology for the purpose, I think firstly, the AI-based image recognition algorithms can automatically identify tissue types, locate lesions, and even automatically adjust the operation pace during the surgery. And additionally, the machine learning can also help applied to pre-operative planning and post-operative evaluation, and it can allow each operation be continuously optimized from history cases. And in addition, advanced AI methods such as reinforcement learning are being explored for allowing robots to improve their surgical skills through trial and error learning. 以上です。
Not so concretely that it is some kind of outline of explanation. So, can you say something detail about for example, the AI technology to be used? Some kind of more exact explanation you can do?
I knew some project during my undergraduation university. I know that as now in the hospital, the doctor will use some technology on this called the AI-based image recognition algorithms to treat with the CT images of the patients, and it can help the doctors um, to make the plan of the surgery.
Okay. Yes, yes, yes.
Uh,
はいはい。Thank you. まあいいや。はい。
So in this paper, the autonomy in surgical robotics, and the author discussed a lot of technologies in this paper, and I just briefly summarized a few of them. So the first, the necessary technologies for autonomous robotic surgery. The first is tissue interaction sensing. Robots must sense and understand the physical properties of tissues to perform safe and accurate operation. And the second is tissue modeling and advanced imaging. So this enable the robot to perceive and analyze the surgical environment for informed decision making. And the third is haptic feedback and force control, essential for delicate issue manipulation and to prevent injury. The fourth is real-time navigation and situation awareness to allow surgical robots to adapt to dynamic environments and make decisions during the procedure. And the also discussed the AI in his paper, and I have the same opinion with him. His opinion that the AI is not the rule based, and it still have some randomness. So the main role of AI in the surgery field is to provide some suggestion and provide some assistance. So the contribution of AI technology for that purpose is the first is computer vision and deep learning. So for interpreting medical images and identifying anatomical structures during surgery, and the second is decision making and cognitive tools. AI systems use rules and probabilistic models to select appropriate surgical actions, and the third is machine learning from surgical data. So robots learn from large data sets of surgical procedures to improve accuracy and outcomes over time. 以上です。
ちょっと、can you show these papers exactly? なんか、show the site page or
Okay.
なんか、can you show us your this?
I'm finding a paper.
We want to share. We want to share.
But the paper is very long.
これ、this page, ちょっと、can you share this review papers, DOI ナンバーとか、このページのアドレス。じゃあ、can you show us, put it on the meeting chat box? これなんていうやつだったっけ
Sorry, I don't know how to share the paper in the
このチャ
chat box.
ットっていうとこ、プッシュ。チャットボタン、プッシュ。and thenこのアドレスをcopy and paste。
Oh, yes.
これ、オートノミ in robotic surgery っていうのが、this is the title of this paper? 合ってるんですか？
Yes.
Autonomy of ね。これか。これか。DOI ナンバーとかないのかな？ DOI。これか。これか。ああ、それで、これで、これで このサイトのアドレスは ?this site's address。
Uh,
うん。
I search this in Google Scholar.
Google スカラーで、
Yes,
これだと思うんだけどな。Autonomy in Surgical Robots。あ、これだよね、きっとね。はいはいはい。ロボットレベル1、2、3、4、5とか。え、これでいいの？アタナシオというやつです。これでいいんだ。このアニュアルレビューズっていうペーパー、ジャーナル。May 2021。で、from this, what you found the most important point?
So because the paper is many talk about a lot of technologies in the surgical field.
うん。
So can you see my screen? And this is the technologies he mentioned in this paper, and I do not cite here all the technology. I just summarized a few of them.
OK, OK。うん。これペーパーか。ペーパー、PDF をダウンロードすればいいのか。あ、PDF ダウンロードすればいいんだけど。はいはい。PDF ダウンロードすればいいんだけど、うん、待ってね。ちょっと待ってね。えーっと、はいはいはい。これ共有を停止して、私がこれを見て、ここのサイトなんだけど、このサイト PDF がダウンロードできるんだけど、これね、
Yes, yes.
これ、Annual Review of Control Robotics and Autonomous Systems っていうやつのボリューム4であるんだけど、で DOI ナンバーはこうだけど、で、これ多分、one important point is that this paper shows the これはなんかチャートでしょ？ここだ。テーブル、Readiness Status of Enabling Technology and Practical Application for Autonomous Level 1 through 4。で、Autonomous Level 1っていうのが、ロボットアシスタンス。ね、ロボットアシスタンス。Autonomous Level 1は、ロボットアシスタンスだよとか言って、で、Autonomous Level 2が、タスクオートメーション。なんか、シングルタスクオートメーション。Single task automation is autonomous level 1, 2. And level 3は conditionally autonomous. conditionally autonomous. ね、これは conditionally autonomous っていうのが task level 3。で、task level 4はもちろん fully autonomous とか high autonomy で here it says high autonomy。ね、まあ、this is the level is categorized into で、what is level 1、レベル0は no autonomy とか、レベル1ロボットアシスタンスとか、how this robot system is the assistance is also the set in this. なんか例えばこの、PDF ダウンロードする必要ないんだけど、サージョン、ロボット、ペイシェントで、なんか、アシスティブシステムが、なんか、information should be given とか、information should be given とか、some なんか information to decide this robot operation is given っていうのが、the role of the robot system in surgery, the surgeon interact with the robot, which in turn provides the clinician with manual guidance or virtual fixture. In this case, the control loop is closed by the surgeon who has full control of the machine or the entire duration of procedure ということで、surgeon is operating, but the system is only providing the information. Yes, as some students said, the very important is the information, the camera image or the force feedback image, force feedback information is very important to decide the surgeon's operation. It's given がレベル1ロボットアシスタンスで、レベル2っていうのはどっかにこうか。タスクオートノミーっていうのは、なんか、some task is given by this autonomous system. だから、partial part is given. ちょっと見て。The role of the rehabilitation system in surgeon. The surgeon provides the necessary information for the robot to accomplish a specific task. During the autonomous execution of this task, control passes from the surgeon to the machine for the time needed to perform the action. We therefore refer to the robot having the discrete control and presented by the switch. Change the surgeon direct operation or the system control autonomously is switched. This maybe some students have already studied about this kind of the switching system. Yes, now you have found which part of this surgical operation can be tried to be operated autonomously.
Which part of you say that is a category of surgery or a category of operation?
Surgery of the category of operation.
For the operation, it should be some using needles to cover to close the vessels or fixing and strengthening the tissues, and as this actually not actually for the removement part. For the assistant parts, they are all could be automatic, just like pull needles, pull the stretch the tissues, and also using pump and other things that to make the operation surface clear.
Yes. First one, some groups try to make it autonomous is the twitching part. Some open catheter part is after the surgery. It must be twitched.
Right.
So therefore, this part is tried to be autonomously done, like this kind of tools usage.
Right.
Yes.
However, for the first principle thinking, to the treating parts actually is not fairly proper for the robotics. We just could design as some easily design that's using just the glues and also the bands to use the robots just to put it in the place and pull the bands to make it closed. This is more based on the robot's operation. We just not need to just stimulate the people. It could, but I don't think it's a good way.
But some of them is very, very useful for surgeons because the complicated skill necessary, the surgical operation by the expert, but this kind of the steering part is easy for others. So therefore, this kind of thing is partially done by robot itself is very good.
It's good, right?
Yes. So therefore, this kind of autonomous laparoscopic robotics Suturing is trying to do. This is University of Maryland and John Hopkins University trials also published in the IEEE これは ICRA is also there. This kind of system, Suturing this part is this open surgically catheter part is try to do this kind of the autonomous Suturing like this. Yes, finding the observing this trench part is observed looks like this, and then the AI is considering how to do this path planning or the strategy planning can be done by the AI system, and then the deed executed by the robotic system is this trials reporting. Yes. This is also the John Hopkins University and the Children's National Hospital in the United States. This is 2022's reporting is also doing like, this is also the same, the level of autonomy, the level 1, level 0, no autonomy, level 1, robot assistance, the robot 2, some task autonomy, some, the level 3, conditional autonomy, level 4 high autonomy, and level 5 is full autonomy. This paper is defined 0, 1, 2, 3, 4, 5. And then this paper is doing some part of the partially doing the autonomous task. これは、comparing the teleoperation surgery and the robotics, the surgery breathing simulation. Yes. Because the living body has a breathing, it makes the moving along the breathing. So therefore, the breathing is also simulated by this system, and the breathing simulator makes this body simulator's movement. And then the camera arm, Suturing robot arm is also here. And then the trial doing this kind of thing. It's also this paper is reporting this part. One is operator is here, and high levels Suturing robot task and planner is given some operation, and this low-level motion controller is doing a trajectory generation, is inverse schematics and robot execution. And this tissues changing, the vision system is capturing this the tissues condition changing. 3D data collection and Suture planning is given some information. So therefore, the operator is remaining inside of this the control loop. Even though some part is autonomously done, but the operator is the supervisory, observing the status of operation in this case, in this trial case. Yes, looks like this. But also only about the Suturing part is only the partially automated, autonomously generated surgical plan. Yes. This paper is also the reporting several years ago, 2022. はい。はい。This is, 誰かを行く前に、I haven't heard from UA, but I have explained. Okay? ちょっと、so therefore the next UA can explain your report. これ中止して。Yes, show your report, please.
First, explore and list the necessary technology to realize the autonomous robot surgery, the multimodal sensor and the perception. The real-time tissue differentiation is achieved through fluorescence sense imaging, force and torque sensors provided haptic feedback for tissue interaction. The decision-making AI architecture. There is a vision language action model that enables surgical robots to understand natural language instructions, incorporate real-time visual data, and take concept appropriate actions. Examine and consider the contribution of AI for that product. First is computer vision. The AI technology denoises, develops, and characterizes surgical lenses while reducing computation time. It can identify key structures with ultra-high sensitivity in autonomically segmentation and certain applications. Adaptive surgical planning. The AI systems enable real-time plan adjustments by modifying the surgical approach based on intraoperative findings. AI algorithms enhance risk management by forecasting potential complications before they occur.
Okay, okay, okay. はいはいはい。どうしようかな。待ってね。なんか、do you have some question from other student? Tenchen, to give some question to him.
Surgery.
えーっと、じゃあ、ちょっと待って。今、はいはい、サンキュー。じゃあ、ちょっとこの部分をシェアしてですね、きっと重要なのはこれで、Ifan found one journal paper like this, and I have introduced this thing. So therefore, this part I will paste it in this meeting chat box. So therefore, if necessary, you can. ちょっとこれは超えちゃったんでダメだ。ちょっと待ってね。超えちゃったんでダメなので、どっかまでにして、ね。まずは、こいつの、説明してくれたやつをここに置いて、これはいいよと言って、もう一つは、私が探したやつで、こいつも後で探すといいよということで、はい、あげます。ということで。ですね。これでいったかな？いったよね、きっとね。はい、です。 です。ということが、はい。それが question 4なんだけど、Okay, now, do you want to know more or discuss more about this part? It's okay. あと15 minutes remaining, so therefore we should move on to the other topic. Other topic はどうすっかな。共有。どこの話をしたい？このロボティックサージェリー、プロコンをしたいか、それとも、ロボティックサージェリー、プロコンのパート、we should discuss about it. あ、そうだな。多分ここだ。Yes. ちょっと、what you found in your working on question 5? Yes. Please share your answer. ちょっと、ペンちゃん、please manage this. Question 5について、Yes, please.
Okay.
Yes, good.
Okay, my answer also question 5 is here, and firstly, for the benefits of the robotic server firstly, it reflected in the improvement of surgical precision. With the help of robotic system, doctor can get a clear view during the operation and complete complex operations with more stable and smaller movements, which is difficult to realize in traditional surgery. And in addition, robot surgery is usually less invasive with shorter recovery time and relative low risk of post-operative infection. As a result, more and more hospitals are adopting the technology to their treatment. However, robotic surgery has also have some disadvantage. On the other hand, the cost of its equipment and maintenance is very high, which is a considerable burden for small and medium-sized medical institutions. On the other hand, some doctors may face a learning curve in the earlier stages, as they operate intermediate machines rather than touching their patients directly.
Cost is one problem.
In addition, although fully autonomous surgical robots are still in the research stage, the ethical, safety, and legal liability issues involved have been gradually raised and discovered and discussed.
Safety problem ね。
And legal.
Yes. No, yes. Okay.
And in my opinion, robotic surgery can be helpful to doctors, especially for skilled doctors, as it can assist them in improving treatment efficiency, and minimally invasive surgery can be less painful for patients. But at the same time, I believe that when promoting medical robots, basic skills training for doctors is indispensable, as the robots have the potential to malfunction or be damaged, and the doctor's own skills are indispensable, and as robots are ultimately only oscillators. robots are auditors. はい。以上です。
Okay. Yes, thank you. Yes. It's to show. But the I have some request to you. I hope you can say yes, this kind of the organization you should do. And the listing up is very important. Yes, the three part, yeah, benefit part, disadvantage part, opinion part, you have to make it. So for example, this is the 5.51, this part is 5.2, this part is opinion part is 5.3. You should say clearly. And then the, for example, disadvantage, how many things you want to say, you should say clearly. You should make it clear. You should show it clearly. So the listing up is very important for example, this is using,例えばなんだっけ。よくこれ、箇条書き。箇条書き。ちゃう、これじゃない。箇条書きってできるでしょ。箇条書き、違うわ。あれこれだ、これだ。これ、例えば、なんか、段落記号じゃないけど、このリストアップってできないね。You can do some listing up. So therefore, なんか、1, 2, 3, 4とか、it's more better to do this. No necessary to use this kind of function, but the one is a cost problem. Second is a training or learning problem. Third is a safety problem. You should make the good heading or leading words, and then explain something about the safety is the something problem, and the training learning is the actually this kind of problem is there. You can say your explanation later. The good reading word and the detailed explanation following. This kind of style is better for others to understand your saying. Okay, so please do like this is my request. はいはい。Thank you. じゃあ、next student, please. Ivan, yes.
According to the paper,
The paper's name is Public Perceptions on Robotic Surgery. And so the researchers conduct an online survey between in 2014. And the survey was distributed via email and social media. And the researchers collected 700 valid responses and analyzed the public perceptions of robotic surgery and opinions on whether hospitals should have robotic equipment and attitude towards surgeon who use robotic surgery. So the pros in this paper is the first improved precision, and the second is faster and less painful, and the third is better ergonomics for surgeons. The ergonomic design of robotic system improves the comfort and posture of surgeons, which can help reduce fatigue during long surgery, allowing them to work more efficiently. And the fourth is remote surgery. And the cons, the first is cost. And the second is concerns about more functions. And the third is misperceptions about autonomy. And the fourth is acceptance and trust. So in my opinion, I think robot surgery is excellent, whether it is in manual operation or autonomous execution, because I think the robot surgery is better than traditional surgery performed manually by doctors, because humans are inherently more unreliable and prone to mistakes. So a simple hand tremor or an error could lead to serious consequence and the injuries.
Oh, yes, good. Yes, you have found a good paper. So based on that, you have reported about this. like a discussion to something is also following it. Oh, yes, yes, good. The good showing the cons part is cost and concerning about the malfunction and the misperception about autonomy, acceptance, and trust is not good enough presently. You have listed up and then explained. That is a very good way to find your, okay? Yes, yes. Hi, good, good. Yes, next student, please.
The pros and cons by the robotic surgery. The pros enhance the surgical position and control. The robotic arms can rotate instruments 316 degrees in tight spaces, enabling access to anatomical areas that would be challenging or impossible to reach with human hands alone. And the minimal invasive approach. The robotic surgery typically requires only small incisions, leading to reduced blood loss, lower infection rates, and smaller, less noticeable scars. And the cons, a high cost and resource intensity. Robotic surgery brings significant financial consideration. Next is the technical limitation and learning curve. The surgeons require specialized training and outcomes significantly correlate with operator experience and the potential complications. While generally safe, the robotic surgery introduces unique risks, the mechanical failures and electrical arcing causing unintended tissue burns. Describe personal opinion to the robotic surgery both in manual operation and autonomous operation. I believe that manual robotic surgery offers significant benefits by enhancing a surgeon's precision and control, while autonomous robotic surgery, through still developing, holds great potential to increase efficiency and reduce human error, provided that safety and ethical standards are strictly maintained.
Yes, yes. Procon is separated subsection, but I hope the listing up the advantage part and disadvantage part numerically. Okay, numerical listing up is very better to show. Yes, thank you. Sorry, the time is limited, so therefore the channel, please.
Because we are actually for the pros of robotic surgery, we change the precision and control even for nowadays. The directly operating system it could change the control precision for for especially for the inner dose the density. For the inner dose operations, traditional ways even cannot actually did it like nowadays the processing and the less of the bleed and so on. And this is actually the first. And also the minimal invasive procedures is just like we could use as we just need a hole or just need from some outer space into the inner environments that we didn't need to do we didn't need to separate and open all the stomach or the chest and also improve the visualization. This is another thing that it's not only for the vision but also for the multimodal for X-ray and also the the supersonic check, we could actually cover this kind of information on just the visual system, and as it, so we could get a better visual and also reduce surgeon fatigue, because of now the surgery, not only the technique, but also need operation, and also all the operation is a kind of repetitive labor. But the cons of robotic surgery, because first for the autonomous robot, it needs the steep learning curve, and even for the remote operation robotics, so we also need to learn how to operate them. And also the limited tactile feedback. The limited tactile feedback is terrible, because actually the tactile is very important for the operation. It could claim that the tissue and the organs, what the situation is and how to deal with it. Actually, before I started to try to research about the computer vision, I'm actually doing something about the electrical tactile. This is just a bump for the surgical robots that could use the electrical signals to convert the tactile feedback to the hand. And also the technical issues in the system reliability. This is actually bound for the this is basically bound for the full autonomous robotics, because of nowadays our autonomous based on the AI and the deep learning. However, the deep learning it is open circle, open road system. It doesn't have the feedbacks. It has calculations. So if we need to use the AI in automations, we need to do the check of the output of the model system. Just like we use people, but we doesn't. The models just like the people. People could do mistakes. A model also.
Okay, okay. ちょっと、Chinao, you have referred the different paper from other students. Can you show? So this is Cleveland technique too. Can you show this the HTTP address put into the meeting chat part, or this references the reference 8. Reference 8, this reference 8, copy and paste to paste to the meeting chat.
Okay, so my computer doesn't have electric. My keyboard is out of power, so now I'm not able to right.
Only saying this fact it is examples of benefit something this part is copy and paste.
My keyboard doesn't it's out of power. I cannot operate mouse.
Only this part copy, Control C and Control P.
Like I can't do import with my keyboard. It's
Yeah. Later, if it's okay, it should be do it later. Yes. No problem. Yes, I will do the. So therefore, what I say is that yes, different students refer the different paper. That is a very interesting point. And then this lecture class should be shared the information each student can provide. That is a very important point, I think.
Sees the difference. We everyone see the different views of the particular question.
Okay. Yes. So that is the most important point I can say today. Okay. Yes. Sorry, the time has been almost 5 minutes over. So so we have to close today's class. Okay. next week is a rehabilitation robot continuously. Yes, we will proceed to the next. Okay. That's all for today. Thank you for attending. See you next time. Bye bye. Thank you.